Hey friends, let's talk about what we did on Friday. So for third hour and fourth hour, we did this on Friday, right? Sixth hour, we got cut short by the lockdown. So we didn't do this. So if you're in third and fourth, I'm going to show you what we did. If you're in sixth, I'm going to show you what we didn't do. Okay, so it says find the big C in this student tool. So what I did is, and again, you don't have to do it the way I do it, but I'm just going to show you how I did it. I looked at figure 1 and I saw 1, 2, 3, 4, 5. Okay. I looked at figure 2. I just looked at this strip and I saw 1, 2, 3, 4, 5, 6, 7. I looked at this strip. I saw 1, 2, 3, 4, 5, 6, 7, 8, 9. So I knew it was going up by 2 every time. So then I figured for this one it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. All right, so I just see it adding by 2 every time. And then I look down this part of the C. Figure 1 is 1 by 2, 1 times 2. This one is 2 times 2, figure 2. Figure 3 is 3 times 2. Then I figured, well, figure 4 must be 4 times 2. Okay. Figure 4 is 4 times 2. This is the way that I looked at it. Is that the way you have to look at it? Nope. All right. So then I said, well, if we go backwards to 0, figure 4 has 11 on this one strip. And figure 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9. And figure 2 has 1, 2, 3, 4, 5, 6, 7. And this one has 1, 2, 3, 4, 5. So this one must have 1, 2, 3. All right. So what about those outside shapes? Or these shapes? And I said, well, figure 4 is 4 times 2. And figure 3 is 3 times 2. And figure 2 is 2 times 2. And figure 1 is 1 times 2. So this one's 0 times 2, right? Figure 0. Beautiful. Now we have to count the tiles. So in figure 0, we have 3. So what this means is we went over 3, x-axis. We went up 3, y-axis. There's our point right there, 0, 3. Then for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. So that means on our graph, we go over 1 and we go up 9. Over 1, up 9. Okay? Figure 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15. And we can tell this is working because if I had a different number, like 16, oh, maybe it would work. But I can see that everything looks linear, right? It looks like it's in a straight line. So 2 over 15. I look at figure 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I count this. 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. So we went over 3, up 21. Over 3, up 21. All right, so far so good. So we're working from the table to the graph. Table to the graph, okay? Now, look at this. It went up 3, 9, 16, or 15, 20. What's it going up by every time? What does it go up by every time? So kids said, well, it goes up by 6, so that's 27. That looks like it works. Straight line still. Linear equation. And then the last one must be 33. That looks like it works too. So we're going up by 6. Now remember that we're going up by 6 because when you have to find your rule, 6 is going to be in there somewhere. 6 will be in there somewhere. Okay? Because we know it goes up by 6. So how do we find our rule? Well, how do you get from here to there? 1 times something. Remember, 6 has to be in there. I'm just going to go 1 times 6. 1 times 6 is 6 plus 3 equals 9. Okay. 2 times 6 is 12 plus 3 equals 15. That works again. What about this one up here? 0 times 6 is 0 plus 3 is 3. Let's try one more. 3 times 6 is 6, 12, 18. 18 plus 3, 19, 20, 21 is 21. That works too. So our rule is, and it helps to know that we're going up by 6s, right? 3, 6, 15. Our rule is we're going to take our number times 6, or 6x, and then we're going to add 3. Okay. Oh, and I can't add a 3 on mine because my keyboard's broken. Yeah, it's like the plus and the equals don't work on my keyboard. But it does work. Okay, it does work. Rest assured. Okay? So our equation was we take our number times 6 and then we add 3. All right, what's the next part of this one? We go into here and we say, let's graph those points. So now they want us to graph the points. So we have to remember 0 was 3. We went up by 6s. 1 was it 7? No, 2 times 6 plus 3 is 9. Good. Yeah, we went up by 6. And then we go up by 6 again, 15. And then by 6 again, 21. And by 6 again, 27. And then 33 and 39. So now they want to know, can you graph these points? So I'm going to go here and I'm going to say up or over 0, up 3. 1, 2, 3. Now, if I get it in the right spot, it should connect. This one, over 1, up 9. Over 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at that. Tells us that we're correct. Next one, over 2, up 15. 1, 2. And then we go up to 15. And then the next one, we go over 3. And we go up to 21. 1, 2, 3. And then we have to go up to, I'm going to pull that back a little bit, up to 21. There it is. Next one, 4 and 27. 1, 2, 3, 4, up to 27. Here. The next one is over 5, up to 33. Over 5, up to 33. That works. And then the last one is over 6 on the x-axis, positive 39 on the y-axis. So we go over to 6. And we're going to take this one all the way up to 39 right there. Beautiful. We just graphed that equation. So that was number 2. Number 3, look like this. Balance this. So right now we have x, right, plus 1 minus 2, opposite negative x plus 3 equals 6, opposite 1, subtract 1. So I'm going to get rid of 0 pairs here and here. I'm going to take everything up to the top. And remember, when we want to solve for x, we want to get rid of the units. We want to get the x's on one side, units on the other. So right now we'll bring these over, and when they cross, they turn positive. So right now we have 2 x's equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positives, which means if we break these up into 2 groups, if 2x's equals 10, 1x has to equal 5 positives. All right, then the last one that we had right down here on 229. Solve for this problem. Negative 3x plus 7 equals negative x minus 1. Right here. So I'll just map this out. We got negative 3x's plus 7. 2, 3, 4, 5, 6, 7 equals a negative x. Subtract 1. All right. What I'm going to do is I want to see all my x's blue. I'm going to pull these all over here. 1, 2, 3. I see a 0 pair right there. I'm going to bring this over here. All right, so what do we have now? We have 2x's equals 1, 2, 3, 4, 5, 6, 7, 8. That means 1x has to equal 4. 2x's equals 8, 1x equals. Now the last problem looked like this. 1 minus 2p plus 5 equals 4p plus 6. And the kids ask, well, what's a p? And I said, it doesn't matter. It could be Q, it could be R. In algebra, it doesn't matter what you call anything. So let's pretend that this is a P, right? So we have 1 minus 2 P's. Algebra, it doesn't matter what you use for the variable. Plus 5, 1, 2, 3, 4, 5, equals 4 P's, 1, 2, 3, 4, plus 6, 1, 2, 3, 4, 5, plus 1. All right, so now I'm going to put all my x's over here, and let's bring all our units over there, and they change colors from positives to negatives. And look at this, 0 pair, 0 pair, 0 pair, and a 0 pair, and a 0 pair, and a 0 pair. So what do we have right now? We have 1, 2, 3, 4, 5, 6 x's equals nothing. So we don't have a solution for this one, right? Because it doesn't equal anything. And that's the end of that problem. All right, we just did the review. Beautiful. Let's get going on to some classwork. All right, friends, here we go.